Okay, now we're back. Now what we want to do is we actually want to start rolling up our sleeves and playing with some data. So now that we know about notebooks in general, we want to try to do something with some intentionality towards a purpose. Our purpose is going to be to explore some data. And not only that, eventually we want to build a machine learning model that's going to take some data and be able to do something with it. You'll remember the example from a couple weeks ago that I mentioned when talking about the confusion matrix, about a model to predict whether or not school would close based upon the weather. And so actually that's the model we're going to build together today. And so we want to first load in our data. We're going to have to clean that data so that we can use it. And then eventually we'll be able to train a model on that data, very much like we did in Scratch a couple levels back, except we're going to, as we said, use the tools that people really use for doing this sort of thing. And so we need to start with the data. So I have two spreadsheets that we're going to load in to our notebook, and then we're going to do something with it. Now, the truth is that data never comes as nice and neat as you would think it would, or as you would hope it would. In fact, there's an old saying, it can't be that old though, because data science as a field really hasn't existed for that long. Really became popular in the zeitgeist in around 2012. But the idea is that data scientists spend about 80% of their time cleaning the data, which is to say that good data and getting data into a useful format is a really super important part of any data science workflow. So what we're going to do is we're going to do that. And so what that's called is often called data wrangling, sometimes data munging, which is taking of data and getting it into the format you need it to be in so that you can train your models. So that's the first part of this data wrangling and feature engineering. So let's start with that. So the first thing we're going to do is we want to look at our data and we want to get a sense of what's going on. So here is a little call. It's obviously to the pandas library. And so something I should note, if you're picking back up with us from the last video and you're just opening up your notebook again and you start running this and you run this and you get an error, it may be because you stopped your notebook, came back, and in order to get this working, this references the pandas library, you would have had to run the cell above that loads the pandas library. So if you just opened up the notebook again, you have to run all the cells above, catch back up to be here so that you have everything loaded the way you need it. So I'm going to go ahead, I'm going to just run the cell. And then what I do is I've loaded in, obviously this read CSV has loaded in some file, which you would have seen is on the server, this table_1. I've put it into a variable called df_1. And then this dot head, what that's done is it basically said, just give me the first 5 rows. If I didn't have that, I would have gotten more of my file and that would have just taken up more space. That not so bad here because they're actually, scroll back till I get back to the right spot. Not too bad here because there are only 20 some odd rows, but you can imagine you might be loading in some data someday that has a lot more rows than that. You don't want to take up all that space. A couple things here. We're using comments sort of liberally here. And you'll notice that I include a link here to a set of documentation. If I open that up in a new tab, I'll see there I can learn to understand what this read_CSV really does. And so it'll tell me about all the different parameters I can pass it. And if I scroll all the way down, it'll tell me about sort of what it does. And you can see there's a lot of stuff to it, but the use is really simple. The simplest use is sort of just what we did, which is that we give it a file name, and it will read that file name into a data frame. And then so here we've set this variable equal to this data frame that we get from that file. And there's our data frame. Like lists, data frames can be made up of different types of data, so different data types. And we can figure out what those are by using this .dtypes to see what they are. So I have my variable .dtypes, and that'll tell me the data types inside. I can see object, object, object. Object is pandas speak for string. I can learn more about those data types here. And so that looks fine. All of these are strings. That's fine. Yes, it's definitely a string. Hurricane, note is definitely a string. That's Hurricane Sandy there. And so again, these are this data we're going to use to train a model, figure out whether or not schools should be closed based upon the weather. The data here is coming from, I went through and I looked at the Twitter account and Facebook and old emails from the university to see when school was closed, because I called facilities and they're like, we don't have a record of all the days school was closed, which I found interesting. So I had to recreate it from social media and the like. That's why you see notes in here. Sometimes some of the notes will be things like Facebook, because it was a note that came out on Facebook. Anyhow, we have that data. We've put it into a data frame. This table 1 is just a table with the date, whether or not school was closed, and then a note. And that might be things like hurricane or Facebook or whatnot, just a little note. And so it's fine that closed is an object and note is an object, but date, really nice. I might want to do some stuff with that date that's sort of mathy. So it turns out there actually is a data type. And so I actually can, inside the data frame, right? Obviously there are data types for the columns inside the data frame. And I can tell it, treat that thing like a date. And so there's actually a parameter. If we looked at the documentation, there's a parameter called parse dates. And I can pass it a list of the columns that I want it to treat like dates. And in Python, the first of anything is 0. So it's what's known as zero indexing. So the first column is going to be the 0th column. And so this is basically saying, take that 0th column and treat it like a date. And so if I go ahead and I load this again, and sort of redid what I did above in the cells above, I'll put it all here in one cell and with this parse date. And I do that, and then I get the data frame. And then I can see now the date is something called date time, which is great. It's not a native Python data type, but we'll be able to make it play nice with Python later on. While we're here, we might as well note that, like, what's going on here? We've got these NANs. Those look familiar, right? From JavaScript, that means not a number. If we were to go ahead and look at the spreadsheet that we had loaded in, I'd see actually those cells as empty. So it's basically taking an empty cell and saying, I don't know what that is. So it's calling it not a number. I have 2 files here that I want to deal with. I have the dates that school was closed, and they also have some information about what was going on throughout the year. And so that's this table 2. I'm going to go ahead and do the same thing. It turns out its first column is also dates. So I'm going to ask it to parse those dates too. And then what I get is this here. I can see I have the date, the precipitation, the accumulation of precipitation, the minimum temperature, the maximum temperature, and the wind for that date. Now something looks weird here. These dates, you'll notice here, one of the things we notice when we turn these into real dates, when we parse the dates, is it changed the format from sort of looking like this, sort of the way I might write them, to this sort of Unix date format, which is always year, month, day, which is a really great way to list dates, because it means if you sort of list them alphabetically, that that they will be in the proper chronological order. But here it didn't do that. So let's go ahead and look at the data types of this second data frame. And oh, look, date is still an object. All these other things it treated as floats, which is a type of number, but it kept the object as kept the date as an object. Now, if I went through and I looked at, if I opened the spreadsheet and I looked through all the dates, I noticed that some of them were a little weird. Like one of them might be something that looks like this, and that does not look like a date, right? At least not for a really long time. And so it's actually, it wasn't able to treat those as dates because it wasn't convinced that they all were dates. So it turns out there's actually a function for converting the contents of an entire column into a data type. So you can change numbers to strings, etc. Here we're going to try to convert the date column in dates into all dates, because obviously it's all objects. We want to try to turn those into dates. For warning, we're going to get an error here, so just stand back. But to give you an idea of what's going on, we have our data frame. We have a column with the name date. We're going to set that column equal to some value, and that value is going to be something from our pandas library. And this function toDateTime and we're feeding it the column from that data frame. So basically we're taking the date column from the data frame, we're passing it to a function. That function is going to spit back a list, and we're saying take that list and make it equal to, or set the column of this data frame equal to that list. And let's see what happens. I sort of warned you there'd be an error, but let's see. All right, we get an error, and if I scroll down to the bottom, which is where the useful parts of Python errors are, it's going to say value error, year is out of range. So that should give us a clue of what's going on, and it's basically what's going on is, remember that weird date we said was going to be in there? I said there's something that looks like this. Well, it's seeing that and saying that year is no way that year is appropriate, so it's out of range. And if we go ahead and we look at the documentation related with this to date time, we'd see that you can do something, and here's a documentation here to it. You can see that one of the things you can do, there's this thing called errors, and we can ignore the errors, we can raise the error, or we can coerce the error. And by default, it raises the error, which says it sort of says something's wrong. That's what's going on here. We ran this through, there was some problem, it just stopped and said, there's a problem. But we could also say it to, we could ignore it, and it won't do anything. Or we could coerce it, and what it'll do is take the invalid things and set them to not a time, which is very much like not a number. So what we're gonna do is we're gonna redo this, but instead of just passing it this, we're gonna add this parameter, we're gonna say errors coerce. And now, instead of spitting out an error, it should take anything that it can't read and it should turn it into not a time. So let's see what happens there. All right, so we've got this. And now reformatted it, so it looks like the dates from before. We look at the data type, and we've got a date time, and then all these floats. That's better. So let's just see, let's get an idea for how many rows we're talking about here. We can have, there's this other function here called length, and we can put it around a data frame, and it'll tell us how many rows there are. And so we can see in our first table, remember we said there were only 20 some odd rows, 20 times the school had been closed in a 5-year period. But obviously a 5-year period has like 951 days in it. Okay, so those are our two tables. So that just was us peeking at our data and getting a look at it. That's sort of what's going on. Why are we doing all this? Well, eventually we want to use this data to answer some question. To do that using machine learning, we're going to need two types of columns. We're going to need features, which are the things that we think might tell us what's going to happen. And then we need a single column containing a target, which is sort of the thing we're trying to predict. What we're going to try to do is going to do a classification algorithm, just like we did 2 levels ago. In Scratch, we're going to try to make something. We're going to say, is it this or is it that? In this case, the is it this or is it that is going to be, should school be closed or will it stay open? And so the yes or no on whether or not school is closed, that's our target. Everything else is going to be a feature. Now, in the end, we're going to want to be clever about our feature selection, because we only want to know things that are going to actually be relevant to our target. And we can talk more about that in a little. But so we're going to need 2 types of rows, features and targets. And so we need to make sure that those things are clean. And we want to choose them carefully. So what I'm going to do now is I'm going to go through some recipes for cleaning and exploring our data, which is to say, looking at all the data in our tables and doing something interesting with them. And so the first thing that we might want to do is merge our data together. And we have these 2 tables. It would be nice if we could sort of put them into one table, and then maybe we can start to do more with that. One thing to know, though, is these 2 types of columns that we're going to make, they're going to want to be numbers. Strictly speaking, the target column, that could stay yes or no, but it's very easy to just say, make it binary and say yes is 1 and no is 0. All the other things need to be numbers, because if you remember from our discussion 2 levels ago, that's how the machine learning models are going to be able to make a classification. So you're going to turn everything into numbers. They're going to figure out where they exist in some sort of multi-dimensional space. They're going to find areas and say, if you're on this side of a region, you're one thing. If you're on that side of a region, you're another. And so they need to be numbers. So what we're trying to do is take these data that we've brought in and turn all the features into numbers, and we might as well turn the targets into numbers too. So, so that's a motivation to keep in mind as we're cleaning up our data. We're going to try to turn everything into numbers. So let's see how we can do that. And the first thing we want to do though is merge our two tables together. So what I've got here is again some comments and a link to some documentation for something called merge. And what merge is going to do is let us take our two data frames and merge them together. Now, I believe I shared this story with you before, but I had a student a couple years ago who was interning at a firm, and they had gotten some discovery. And that discovery was basically a bunch of spreadsheets, and they were going to have to hire an outside consultant and whatnot. And my student who had taken this class and done this lesson was able to use this merge feature and basically say, hey, no, we can take those two sheets and we can merge them together and we can explore the data. And they thought he was magic, and they eventually offered him a job. He ended up getting a better offer somewhere else. But the point is, these things can be powerful tools for being able to look at the data you have. And so here we have this, we have a variable we're going to call single table, because we're going to put everything in one table. And we're going to take the data frame 2, and we're going to merge it with data frame 1. Okay, so we're going to put them together. We're going to talk a little bit more how this happens here in a second, but let's just see what happens if I run this. And then I'm going to do the row count. I'm going to say, give me the number of rows in single table, right, using that length function. And then here we'll go ahead and we'll look at the single table. We'll preview its first several rows. Let's run that. And here what we've done is we combined the two tables together. Well, how did we combine them together? Well, you'll remember we had there's a common column, right? The date was this, there was a date column in both of these tables. So it has combined them on date. And so it basically said, here's the dates, here's the accumulation on that date, the temperature, min and max, the wind, whether or not it said closed, and then the note. Right, so I had the head on here, so I only see the top ones. Let's see what happens if I do sort of more of them. And then I can see here, so obviously, and this is interesting, their row count is only 19. And one of the things is I notice it's only showing me those dates where, yes, school was closed. So what's going on here? 19 is not, I need more data than that. I need not just the days that the school was closed. I'm going to need all the dates when it was open too if I'm going to train my data, right? I have to have examples. If we think back to 2 levels ago, I have to have examples to give to my machine learning classifier. So what happened? Well, it turns out, why 19 rows? And it's because of the way that things were merged. So if we sort of think of these Venn diagrams here, as on the left we have the first table, and on the right we have the second table. There are different ways that we could combine tables, right? And the default for merging these two tables together is something called inner. So it's basically merging them and looking for the overlap. So if we were merging on the idea of a common date, it's basically going to just keep those rows where that date showed up in both of the tables. So that's this inner join. And there are different ways we could join. We could do a left join, which says basically keep all of the rows in the first table and then attach to them the rows you find from the second table. Or we could say keep all of the rows from the second table and attach to them all of the rows from the first table. Or we could say basically keep all of the rows from all of the tables and then we just see where they overlap. And so what we want to do is obviously not do this inner join, which is going to restrict the number of rows we have to just those where the date appears in both tables, which we know is not going to be bigger than the smaller table. We want to keep all the rows from the larger table, which is the one that has every day in it. And so what we can do is here we can redo a merge. It turns out that there is a parameter called how, and we can say how, and we can say left. And actually, it had before determined that we were merging on the common column of date, but we can be very explicit and we can just say that too. So here we're going to say, be very explicit, take the second table, merge it with the first table on the date column, and we're going to do it left. And so since table 2 was first, it's going to be the first column here. So it's going to be this one, first table. And if we're doing it left, then it's going to keep everything in that first table and then see where it matches up. And so let's see what that looks like. Again, we're going to take the head there and we'll see the row count. And there we go. We've got 951 rows. And you'll see a lot of, we got NaNs here. Well, that's because these are the rows that were in table 2. They obviously didn't have matches in table 1. So it couldn't give us value for closed or note, okay, which is fine. And now we have actually a row for every day in our data. And so if we want to look at a single row, we can just look at, a single column. We can just look at the head of that column, right? So here we can, using our same head method, we saw this before, sort of the way to just talk about a column. And so there we go. That's our accumulation column. You can run functions on the contents of a column. So for example, I could find the mean of the accumulation, find the biggest entry, right, the max, find the smallest entry, the min. So if I do that, I can see, oh, well, the average accumulation was less than an inch. The maximum accumulation one day was 15 inches of precipitation. And of course, the minimum accumulation was 0. But it's not just math that you can do on these columns. There are other fun things like this unique method here. Here's the link to the documentation, which tells you what exactly it's doing. Part of what you should be learning here is how to read documentation. So you might want to look over at that. But you can sort of guess what's going to happen here. I'm going to print out this. What I'll do is it'll, remember, this is the note column. This shows me all the unique entries. So one of the entries, obviously, for the note column is not a number, because remember, when it was blank, it was turned to not a number. But then also, I seem to have used the note hurricane, early Facebook, so that meant early release announced on Facebook, Facebook for announced on Facebook, early for just being an early release, email for being announced on email. You can also explore rows with a specific value. So here is my data frame. I can put inside brackets here, I can say, take this data frame and show me only the stuff where, and we know this looks like a column, right? So where the column closed. And then we see, similar to JavaScript, we see this evaluation where column close is equal to yes. And so what this is going to do is it's going to show us, I'm going to put it into a variable here called temp. What this is going to show us is there are rows, 19 rows, basically where the closed column was equal to yes. Okay, now that's interesting because 19 is smaller than what we said that original table was, which was 20 some odd. So why is that? Well, that's because it's looking for exactly where this is equal to yes. I went through and I made sure that the data I fed in looked like data you'd see in the real world, which is to say that yes wasn't always written the same way. Sometimes yes might have been capitalized. Sometimes it might not have been. So we need to account for that when we're cleaning our data. So for example, we'll have a column closed. We can set it equal to column closed, and then we can use this string upper to turn all of the contents of that column uppercase. And then when they're all uppercase, then we can say, we'll see where that column was equal to yes, because everything will be uppercase. Let's see what happens there. Well, again, it's just 19, but I guess I didn't have any ones that were lowercase there. You can do invert, you can do sort of the inverse. You can do not equal to. So here we say show all the ones where it's not equal to yes. Okay, 932, obviously the majority of them. And you can do evaluations, like show where accumulation is greater than 1. Yeah, right, you can see there are 27 days. So if you want to do these comparisons, again, here's a list to operators, in this case for Python. You can also establish whether or not something's null or not null. So this would tell us all the ones that are not, where it's not null in the closed column, or the inverse, which would be is null, which are all the ones where it is null. You can make copies of these data frames, and this will allow you to work with them, sort of do new things to them. So I can make a process table variable that contains this single table bit, and we'll do that there. We'll sort of copy it in. Doesn't look like anything's happened, but now I can do stuff with it. If I was just to echo out process table, and if I just sort of redo this, I put process to have it echo it out. So I can see there's my table, but it's a copy now, so I'm not going to have to worry about messing it up. That's something you do have to worry about. If you load in a data frame and you make changes on it, then you've made changes on it. So it's nice to work with a copy. So here what we're going to do is, if you have a column that contains a set of labels, you can turn them into multiple rows containing numbers, right? Because remember, the thing is we want to turn everything into numbers, but these notes are not numbers. And so this is a fun little bit of code here. It's going to use this thing called concat, which means sort of add on to each other. You don't really have to understand how this one works just to sort of get a feeling for it. But it's going to take this process table, the notes column, it's going to run it to this thing called get dummies. And basically what it's going to do, watch, this is cool. It sort of had all of the stuff we did, and then it, from the note, expanded out, and it took those unique columns, those unique values, as early Facebook, email, Facebook, and Hurricane, and turned them into numbers. So if it had early Facebook in it, this would have a 1. If it had email in it, it would have a 1. If it had Facebook in it, this would have a 1. So you can see these notes don't have anything in them. If I get rid of this head there, this can be, look for one where it's not. There we go. So here's yes and email. And so that's the emails in the note column, which means that here in the email column, it says 1. So it's basically, it's found a way to take the stuff in that column and turn it into numbers by creating a new column for each unique value in the note column, and either having it be 0 or 1. And that's how we're going to get at turning those text bits into numbers. You can remove unwanted columns, right? So if I want to remove a single column, I can tell it to drop the email column. And then for multiple columns, I can do something like this. I can drop and then put it inside a list. Here I've commented out Facebook, so I could either include it or not include it as something to drop. And you can see there that what it is, here I displayed there I dropped email, and then here I dropped early Facebook. So here they still are here, and then I drop them in this one. If you want to make a new table from a subset of columns, so instead of saying I want to drop these, I want to make one from just select ones, I can do this here. Again, I'm doing this as a copy so that I don't actually change things. And you can just come back here. And what I want you to think about these as recipes, which is to say that these are not things that I don't want you to have watched this thinking, oh, I have to know every little thing that I'm going through here. These are recipes that you're going to be able to know about and go back and reference. You can rename columns like this. This is just syntax to do this. And you can replace values in a column using logic like so. And so this is actually really exciting. I can say, take a column closed if it's equal to yes. And so for a row where the column closed is equal to yes, take that column closed and set it equal to 1. So basically now I can turn the yeses into 1s. And if it's not equal to 1, then I can turn it equal to 0. So that takes all those non-numbers and turns them into 0 because those non-numbers weren't turned into 1s. And so what that allows me to do then is I've now taken that and turned all those non-numbers into 0s, all those yeses into 1s. And so I've turned that column into numbers as well. And so that is just some data cleaning. Let's take a little break here. We'll come back and I'll talk to you about feature engineering.